So my presentation is going to focus on preparing all students for post-secondary success by a concentration on looking at building reasoning and sense-making skills and strategies in high school. This is designed as a teacher presentation for professional development, part information-based and then also part strategy-based. So before we get started, we should take a look at what I'm referring to whenever I say reasoning and sense making. Although they're very connected, they do still have definitive definitions. So reasoning and sense making together refers to a student's ability to use math in a meaningful way. So the reasoning part of that is referring to the process of drawing conclusions based on evidence or assumptions that they make in class. And sense making is referring to developing an understanding of a situation, context, or concept by connecting it with existing knowledge. And that's definitely an area where I think students currently struggle, is trying to take what they know and connect it with something that they're learning. So what are some concerns related to preparing kids as they move through high school and on to the next phase of their life? So one thing is that not all students are going to have the skills that they need for college or the workforce when they finish high school. So there's a lot of research that goes into looking at the value a high school diploma has, and what a lot of people in college admissions and the workforce are seeing is that even though a student has a high school diploma, that doesn't necessarily mean that they have acquired the skills necessary to move forward. So college bound does not always mean that students are actually ready for college in terms of the skills that they have. And one thing that came up in the research was that many students, although they have a high school diploma and they have taken all their math requirements, that they have to take remedial math and reading in college. And in fact, that also could in turn lead to a lower graduation rate or fewer students who have to take that remedial class in college completing their degree. And the third point here, college or workforce, students are going to need the same skills regardless of where they're going after high school. And I think it's a common misconception that people think if you're going into the workforce that you don't need high-level math. But in fact, it is seen throughout a lot of different jobs in needing the same skills that students going on to college would need. So where do we start? I think everybody is already tackling the bottom of Bloom's taxonomy with remembering, recalling basic concepts, that kind of repetitive practice. But the focus is going to be how do we get out of the bottom and move kids into the understanding, applying, analyzing, evaluating, and potentially into creating so that they have those skills when they finish high school. So the goal of this presentation is to share information and strategies so that we can tackle this goal here. So ensuring that all students are prepared for post-secondary success by focusing on reasoning skills and sense-making in high school math curricula by offering equal opportunities for all students to access high-level math. Again, going back to that idea that regardless of if students are going to college or into the workforce, they're going to need the same level of math. So what do we do now? So on the very basic level, we need to be incorporating tasks that require students to figure things out on their own. So these are going to be surrounded by you asking probing questions, and I used a few examples here. Again, very basic. What's going on here, and why do you think that? So this is going to rely on incorporating reasoning and sense making in all parts of math curriculum. Again, we probably traditionally it's easier to incorporate these skills in geometry, but there are many opportunities in the math curriculum to be incorporating them, and specifically reasoning opportunities in high school relating to numbers and measurements, algebraic symbols, functions, geometry, stats, and probability. So really, students should be having these experiences in all parts of their math curriculum. Also, we have to ensure that all students are having equal opportunities to this curriculum and to math and high levels of math. So course and tracking providing opportunities for all students to offer or all students to access challenging curriculum. And I found a few interesting statistics here. So currently, Only 4 states require Algebra 2 as a high school requirement, and then by the year 2020, only 20 states will require 4 years of high school math. And I know in our readings and from what I've found in my further research, that 4th year of math is critical to prepare kids for college. And oftentimes students are going to be fulfilling their math requirements ninth, 10th, and 11th grade. And then that year before they go off to college, they're missing out on a lot of opportunities to further build their reasoning and sense-making skills in math. So that 4th year is definitely critical. Student demographics, so making sure success is promoted equally among all students. And then this last point very much relies on your own kind of language and how you speak with students in the classroom, but beliefs and bias. So making sure that all the things that you say are positive or neutral and not in fact negative in any way, even if it is subconscious, making sure you're very mindful of that so that all students are held to the same high expectation. Okay, so a teacher's guide. This is kind of like your framework to get started. So make sure you're selecting worthwhile tasks. Establish a mathematical thinking norm in your classroom. This should be done early and often. Students should almost, in a sense, be trained to have this mathematical mindset. Guide purposeful discourse centered around reasoning. So this concept of discourse came up a lot. And the more students are talking about math, the better their reasoning skills are going to be. Varying assessments to evaluate progress and inform instruction, so making sure you're giving everybody opportunities to excel. And then this last point, make sure you're reflecting on the things that you do and the success that you have, and then how you can use that to further inform instruction. So this is just an example of some short phrases you can use to help encourage discourse, and specifically mathematical discourse. So getting kids to talk about math in a conversational way. There is going to be arguments involved, and they should be structured and productive. So I agree with, and then elaborating why. So discussing how you got there. I noticed, and then you can kind of fill in the rest here. So I have a question about, I disagree because. So there's going to be challenges, and that's where a lot of this reasoning comes in. And students can really develop those reasoning skills through classroom discourse. Okay, so what should we be expecting kids to obtain before they finish high school in terms of their math courses and being ready for college? So they have to be able to analyze a problem. And what does that mean exactly? They have to be able to identify relevant math concepts, procedures, or representations, define relevant variables and conditions, seek patterns and relationships, look for hidden structures, apply previously learned concepts, and make deductions and conjectures. So on a very basic level, making sure we're focusing on those parts of analysis. So this is just an easy concept here, more basic probably than even a ninth grade math, but making sure if they've seen this coming up through their schooling, they're going to be a lot more flexible to it in high school. If this is not something they've seen coming up through their primary grades, then it's going to be more of a challenge getting them into that mindset. But a simple example here. They should also be able to implement a strategy. So this involves making use of a procedure, organizing the solution, making logical deductions, and monitoring progress towards the solution. Again, we're focusing on the concentration in math, but a lot of these are going to be cross-curricular. So they're going to be using similar strategies, similar reasoning in other aspects of their schooling. And hopefully they can get to the point where this becomes transferable. So they're seeing it in their literature courses, they're seeing it in their science courses, or they're seeing it here and using it elsewhere. And then that will make their use of it easier. Again, another example here, looking at how to implement this in a class. So this is giving kind of like a challenge problem or a scenario that students can really relate to the task on the side here. And they are going to have to come up with an approach to solve this. On the right is a more traditional way that maybe this would be covered in a classroom. And you can see the difference here where the kids are really getting involved in the reasoning of this and how to set it up and how to problem solve. Again, another example here, using what you're developing in the class. Again, just another example. Third point, students should be able to reflect on a solution. This means interpret a solution, consider reasonableness. I really like this one because I remember learning this as a student, and it was very helpful, and I don't know that a lot of our students are using this, identifying whether or not it makes sense. Revisit initial assumptions, justify or validate your solution, so just figuring out a way to check it against what you've already worked through. Refine arguments, reconcile differences, and generalize a solution. So my challenge for you, so if this were a professional development, I would propose this to the group and give them some time to think it over. And as I cite here on the bottom, discuss it in a small group. So this is a challenge problem. It's looking at miles per gallon and comparing a compact car that gets 34 miles per gallon with a hybrid that gets 54 miles per gallon. Replacing a sports utility vehicle that gets 18 miles per gallon with a sedan that gets 28 miles per gallon. Or C, both changes have the same amount of fuel. So this would be kind of a brainstorming and sharing activity within the group. And then here is just a sample response. So there's a lot of different things that could come up in conversation. This is just one example of how you could look at it. This student decided to use a 100-mile trip as like the baseline, and then that way they were able to calculate differences between the different vehicles. Again, a second challenge, so this would be a time for the teachers involved in the training to think about how they would usually or typically cover finding XY intercepts of a linear function. So thinking about reflecting on their own teaching practices, how is it currently taught, and then offering up some alternative approaches. So ask students to look at a graph and identify the intercepts. Ask students why these points might be of interest to someone trying to interpret the graph. Create a context for a graph that requires interpretation of one of the intercepts. Ask students to create their own rules and to compare these to the textbook rules and why do the rules work. This one's really good because it's starting to get them to think about all these procedures they're used to following and reflecting on why does it work. Ask students to graph a messy equation that's difficult to graph, 33x plus 14y equals 231. So again, this is having the teachers involved in the training reflecting back on their own practices and seeing a specific way where they can incorporate new strategies. So it's just some final tips in conclusion. So incorporate tasks that require students to figure it out. Give an appropriate amount of time for students to fully engage in the task. This also relates to wait time. Students are going to take longer to arrive at the things you're asking them to do. So make sure you're giving them a appropriate amount of time for whatever it is you're asking of them. Resist the urge to tell them as much as possible. You want to let them struggle through it to a certain extent. You can be there for assistance, but you really want them to be the ones to figure it out. Ask questions that will force students to think deeper, and establishing a classroom climate in which students are comfortable arguing and critiquing. So this one's important, especially at the beginning of a year, to make sure students know what the expectation is and that all students are part of, as I was referring earlier in the presentation, this mathematical discourse and that they are comfortable arguing with each other in a way that is appropriate and productive. Just some resources I used here for the research I included.